Hello, and today's purpose of the day is I can add and subtract polynomials. So for our warm-up, I want you to think about the following questions. What are like terms, and how do we combine like terms? Please be ready to share your answer with your table mate and with the class, or feel free to jot a few notes down right now. So adding and subtracting polynomials. First thing to do is choose a method that you like, vertical or horizontal, or perhaps maybe a different method. Keep in mind to check for double negatives. Be sure to combine all like terms, and be sure that your answer is in standard form. And again, to recap what standard form is, that means greatest degree to the least degree. So one method that works very well is called the vertical method. So vertical means straight up and down. So if I were to line up these polynomials vertically, I want to line up the like terms. So 7y squared plus 2y minus 3, and I'll add to that, and I'm going to put this polynomial in standard form as well, which means my greatest degree, 5y squared, comes first, minus 4y plus 2. And now I'm going to go ahead and add these vertically like I would with just integer value numbers. So negative 3 plus 2 is negative 1. 2y minus 4, or plus negative 4y, is negative 2y. And 7y squared plus 5y squared is 12y squared. And now your answer is already in standard form, so you don't even have to worry about rearranging anything. It's all ready to go. Okay, now if we look at example 2, and again if I use the vertical method, I'm going to line up my terms vertically. So I have here 2x squared minus 2x plus 3 minus, now this polynomial here in standard form would be 3x squared plus 4x minus 5. Now I could also write this with distributing my negative through. So here I have the negative in my first example, and I just have to remember to take each term. For example, 2x squared minus 3x squared. 2 minus 3 is a negative x squared. Now a negative 2x minus 4x. A negative 2x minus 4x is negative 6x, and 3 minus negative 5 here is a positive 8, because two negatives make a positive. Or if that was tricky to follow and making sure to subtract every term, what we could do is when we write this out here in standard form again, 2x squared minus 2x plus 3, I could say plus, now I could distribute this negative to everything. And this would be a negative 3x squared, a minus 4x, and then a plus 5. And now I could just go ahead and add these two polynomials. So 2x squared, and I did forget a negative here actually, because I didn't distribute the negative to that 3x squared. So 2x squared plus a negative 3x squared is a negative x squared. Negative 2 plus a negative 4 is a negative 6. And 3 plus 5 is 8, so we did end up getting the same answer. So it just depends if you want to distribute that negative or if you'll remember to actually subtract every time like we did in that first example there. The horizontal method, similar to the vertical method, is just a great way to organize all your like terms. And again, if you prefer another method, you could always do that. So horizontal, I have 4x squared plus 3x. Make this look a little bit nicer. Plus 3x. Oh, wait, I have to line up my like terms. And so that's not an x squared. I have a plus negative 7x squared. And I'll write these terms alike horizontally, so right next to each other. And then I'll add to that, because I'm adding here, would be my x terms, which would be negative 2x plus 3x. And then lastly, I have a 7 minus 9, or plus a negative 9, right, because we're adding both these polynomials here, and now I can go ahead and combine like terms. So here I get a negative 3x squared, here I get a 1x, and then with my numbers I just get a negative 2. And so my final answer here is negative 3x squared plus x minus 2. Another way of using the horizontal method is lining up your terms, or maybe like circling or boxing them, and a 4p cubed, ooh, there's no p cubes over here, so I get 4p cubed. Now I look at p squareds, and I have none over on this first polynomial, but I do right here, but this is like a 0p squared here, and then I'll have to subtract 3p squared, so I get negative 3p squared. So again, I'm still looking at these terms horizontally, so right next to each other, but I don't necessarily have to show all my work and write them out. And then if I look at here, the 7p minus a negative 9p, again, 7 minus negative 9 is chop chop, really is plus 16p. And then I have negative 8 minus a 2, which is negative 10. So this would be my answer here. And that's another way to use the horizontal method as well. Now let's take a look at a few word problems. The perimeter of the figure is represented by the expression 7x squared minus 10x plus 2. Highlight that. Write a polynomial that represents the measure of the third side. So we know the total area, and we know side 1 and side 2, so we need to find the measure of side 3. So what could I do here to figure out the third measure? Yeah, we could add up, or find the sum, add up the two sides that are given, then take that amount and subtract that from the total. So let's give this example a go. So I'm going to add up 6x plus x squared minus 3 to 8 plus 4x squared minus 15. So I have x squared plus 6x, I'm going to write these out, minus 3, and I'm going to add to that 4x squared minus 15x plus 8. And what I end up getting is negative 3 plus 8 is 5. 6 plus a negative 15 is a negative 9x. And x squared plus 4x squared is 5x squared. So I end up getting 5x squared minus 9x plus 5. And so I have to take that away from the total here, which was, I'm going to get a little bit more space here, 7x squared minus 10x plus 2. And I'll subtract from that what we just calculated for the total of the two sides of 5x squared minus 9x plus 5. I'll subtract here, and 2 minus 5 is negative 3. Negative 10 minus negative 9 is really plus. So I get a negative x, and then 7x squared minus 5x squared is 2x squared. So the measure of the third side here would be 2x squared minus x minus 3. All right, let's take a look at one more word problem. Billy is planting a garden on the perimeter of a rectangular patio. First part of the question says, if the perimeter of the patio is 180x and one side measures 24x, find the length of the other side. So let's draw a picture. Pictures always help to perhaps understand the word problem. So here, the perimeter is 180x. We know one of the side measures is 24x. So that means this other side here is 24x. So we got to figure out the two missing sides. Well, the one missing side, because then the other side will be the same. So if I know the perimeter is 180x, and I know that side 1 is 24x and side 2 is 24x, side 3 and 4 are unknown but they're the same, let's subtract the sum of 24x and 24x, which is 48x. And then when we get our answer, since we know both sides are the same, we'll take that answer here and we'll divide it by 2, and that will tell us the remaining side length. So 180x minus 48x. is 132x. So if I take 132 and divide it by 2, I get 66x. I'll actually write that in the right spot, 66x for each side length, and that would be the length of the other side. Question 2 says, write a polynomial that represents the area of the rectangular patio. Well, we know the patio here, if I draw another picture, is 24x by 66x. An area is length times width. We know how to figure out this area. So we can take 66 times 24 and get 1,584. And then we know x times x is just x squared. So our area here would be 1,584 x squared units squared. Thanks for listening and have a great day. Remember, 7.5 was all about adding and subtracting polynomials, which is really just combining like terms. So you're going to see a few extra challenging word problems in your classwork here for tomorrow.